Talk a minute about something that's kind of new in math called experimental mathematics. Now, when you hear the term experimental, you probably imagine someone who's peering over a microscope, looking at data, and they're seeing something, and they're like a biologist or a chemist doing some experiments with a test tube. So we typically think of experiments as happening in the life sciences or the physical sciences. So what would it look like to do an experiment in math? The traditional idea of math may be that you have a process that you know how to follow. So you may be thinking something like, I'm going to solve ax squared plus bx plus c equals 0. I just know a formula that I want to plug in. But that's not always a helpful framework because there are math problems where no one knows the answer. There are math problems where no one has known the answer for hundreds of years. And so while it is awesome if you can just sit down and figure out a logical process to follow, lots of times mathematicians are searching the space of symbols for things that they don't know yet. They're walking around like a question spider, trying to figure out, kind of feeling their feet, seeing what's around. I think it's important, I did not come up with this idea. This is an idea that's been emerging in the mathematical community over several years, probably at least 20, since the advent of computers. And it's something that we can explore because we have computer-based tools as well. To begin with experimental mathematics, we can begin with noticing a pattern, and then we notice something we can vary, and something that could vary in response to that. So I want to start by looking at something familiar from Calculus 2, which is if I have three different curves, and I can write each of these curves as a power function. So I'm going to be thinking about curves that have the form y equal x to the p, where p is a real number. And so depending on the value of p, the definite integral from 0 can either converge or diverge. We could look at our three power functions here, x to the -1, x to the -3, and x to the -1/2. And we could set up an integral from 0 to 1 of x to the -1 dx, and it tells me that's undefined. So that's a data point, right? That's a data point that if I look at p, and then I look at the integral from 0 to 1 x to the p dx, that when p is equal to -1, the value of this definite integral is undefined. So I'm going to start making a table of values here. I look at this and start to try different numbers and see what happens. So my other thing I had to investigate here was x to the -3, and it tells me that's also undefined. And another thing that I had here was x to the -1/2, but that actually takes on a value. If we did this exactly, we would see that this answer was 2. But the important thing is that it is a defined number. It converges. I have three data points here, and I'm going to start making records of my data points to see if I can notice anything about a pattern that might work here. So far I have three data points, which is that when p is equal to -1, this integral from 0 to 1 of x to the p diverges. When p is equal to -3, this integral from 0 to 1 of x to the p diverges. And when p is equal to -1/2, this integral diverges. So I think it's going to be good if we set this up in a structure where we look at the fact that p is a real number. I can investigate this with the value of p, and I can use different colors to set up depending on whether it converges or diverges. And now I can start, and I can just start trying to fill in more data here. What if you looked at changing this to be x to the -2? Okay, at that point, this integral diverges. And if I changed it to x to the -1.5, it diverges. So what if it happens, we know at x to the -1 that this diverges. What if I bump it just a little bit to like 0.75? The only thing I care about here is convergence or divergence. So it converges at this integral converges when p is -3/4. And now we sort of have a conjecture. We might guess that maybe we have a guess, maybe we don't. But notice so far we've only tested negative numbers. But we definitely see a change in behavior here at p equals -1. And let's look and see what happens if we bump this off of p equals -1 just a little bit, like 0.9, 0.99. At 0.9, it's actually undefined. They struggle with what's called round-off error. And so I'm going to go ahead and tell you, to not lead you too much into confusion, that when you're dealing with this type of situation, that round-off error is an issue. So you have to be careful with it. And even though when we work it out exactly, we will see that this integral converges when we do the analytics, this integral converges, but the computer thinks it diverges. And the reason is that when it's doing this 0.99 for this tool is so close to 1 that it's basically getting pulled into x to the -1. So that's not true. It's something you have to be careful about. But the computer is helpful for letting us get started. And the second thing that we really want to look at here is when I look at this, I notice I've only tested negative numbers. So I also want to try to test positive numbers. Now, it's really cool that I've been able to type these in one by one, but instead I'm going to create a slider. I'm going to put x to the p and add a slider here at x to the p. So this will allow me to generate data really quickly. For instance, right now I see that when p is equal to 0.5, that this integral converges, and I'm going to be looking at this number that right here, so that if this is a number, then this integral converges. If it says undefined, that probably means it diverges, as long as we're not dealing with round-off error. So that's what I'm looking for here to try to track this data. And I can sort of test a lot of points at once by dragging the slider. So notice I'm getting numbers all the way up until I hit -1. So all of these positive values, I'm getting awesome. And then I hit p equals -1, and suddenly this is undefined. So that confirms what I was looking at. And my conjecture, a conjecture is a guess that you make based on what you've seen so far. My conjecture is that definite integral from 0 to 1 of x to the p dx, my conjecture is that this converges if p is greater than -1, and it diverges if p is less than or equal to -1.